Good evening, everyone, and a very warm welcome to the NPTEL's sixth live interactive session on the course Engineering Metrology. The course instructor for this course are Professor J. Ram Kumar and Professor Amandip Singh Oberoi. And I am an additional TA Shubham Jaiswal. I am a research scholar in the Department of Material Science and Engineering at IIT Kanpur. So in this live interactive session, we will be going to solve some samples problems related to your weekly content, which will in turn will help you to solve your weekly assignments. So as this is the live interactive session, I hope for the interaction, and so we will together try to solve some samples question. Okay. So during solving, if you have any doubt in the question or how to proceed, you can ask. So let's begin. So before going to solve the questions, first we quickly recapitulate what are the contents that have been covered in the last week. Okay. So in last week we have seen the measurement of screw thread. Am I audible, na? Mr. Prashanta, Mr. Janardhan, am I audible?
Yes, sir.
Sir, audible.
Yeah, so in last content we have seen the measurement of screw thread. In that we have seen the screw thread terminology. In that we have seen the what is screw thread. Then its ASTME definition. Then second we have seen the form of thread. Okay. After that we have seen what is the external and internal threads. Then we have seen the axis of thread or pitch line. Okay. After that we have seen the angle of thread, flank angle, etc. Okay. So after that we have seen some terminologies like what is pitch, what is helix. After that, what is the lead, what are the major and minor diameter. Similarly, we have seen the effective diameter. Then also we have seen the what is addendum and dedendum. Then what are the single start and multiple start threads. Okay. And then after that we have seen measurement of the screw thread. Okay. Measurement of screw. Measurement of the screw thread. Okay. And in that we have seen the major and minor diameter using bench micrometer. Then we have seen effective diameter calculation. In that we have seen one wire method, two wire method, three wire method, and the base size wire. Then we have seen the measurement of pitch. After that we have seen the measurement of pitch. Okay, in that we have seen the pitch error. After that we have seen the thread gauges. Okay, thread gauges. So in thread gauges we have seen the different types. First one is the depending on the type of application. We have seen working gauges. Then second one is inspection, and third one is our master gauges. Then we have seen the measurement of pitch, that is the based or the thread gauges based on their form. So if we differentiate based on their form, we have seen the plug screw gauges and ring screw gauge. Okay. So after this we went to the gear. Okay. So in gear we have seen the types of profile, that is involute and cycloidal. Then we have seen the types of gear. So the types of gear that we have seen are spur, worm and worm wheel. Then we have seen the bevel. After that some more gears like herringbone gear, helical gear. These are the some gears that we have seen. After that we have seen the errors in spur gear. Okay, spur gear. So in this topic we have seen that is the what are the different types of error that are present in the spur gear. That is the first one is that we have seen is gear blank runout. Second one is gear tooth profile. The third one that we have seen is the gear tooth. Error. Then we have seen the pitch error. Then we have seen the runout error. Then lead error and assembly error. Also with this we have seen the different gear terminologies. What is base circle, addendum, dedendum. Similarly, what is the flank and face, tooth thickness, etc. And after that we saw some instrument like to measure the tooth thickness, like gear tooth caliper. And after that we have seen some composite method of gear inspection. Composite method of gear inspection. Okay, so in that we have seen the Parkinson's gear tester. So this much we have seen in our last week. So depending on this based on this content, we will try to solve some samples problem. Okay. So we will move to our first problem. I hope everyone is able to see the screen. Okay. The first question is, the screw thread gauging plays a vital role in scientific metrology, industrial metrology, legal metrology, dynamic metrology. Can anyone answer this? Mr. Chandu, Mr. Pramod, Mr. Janardhan, Mr. Roderick. Anyone?
Sir, industrial metrology.
Okay. And why is it so? Okay.
Because the industry's thread are used, sir.
So the correct answer is, yeah, Mr. Chandu, you are right. The correct answer is industrial metrology. Okay. So in industrial metrology, we need to quickly inspect our samples that are produced, whether that are under our limit that satisfy our criteria or not. Like it falls under its limits and tolerances. So that's why to quickly inspect these things, we use the screw gauge in industrial metrology. So that's why the screw thread gauging plays a vital role in our in industrial metrology. When it comes to the scientific metrology, we can use the inspection gauges or master gauges. Okay. So, but for industrial gauges, means for in the mass production or when we want to check whether they are falling under limit or not, then we can determine that quickly using the gauges. So that's why thread screw gauging plays a vital role in industrial metrology. So moving to our next question. The screw thread is a helical ridge produced by forming continuous helical groove of a uniform section on the external or internal surface of a cylinder or a cone. This definition of screw thread is given by ISO, ANSI, BSI, ASTME. Anyone? Anyone? Yeah, Mr. Jandu.
ISO, sir.
Any other option? Anyone? Okay. So, Mr. Chandu, you are wrong. This definition, that is the screw thread is the helical ridge produced by forming a continuous helical groove of uniform section on external or internal surface of a cylinder or a cone, is given by ASTME. Do you know the full form of ASTME? Anyone? What is the full form of ASTME? Okay. So ASTME stands for American Society of Tool and Manufacturing Engineers. That's why ASTME. Okay, so this definition is given by the ASTME. So moving to our third question. Which of the following is an internal thread? Nut, bolt, stud, or none of these? Anyone? Okay. I am repeating the question. Which of the following is an internal thread? Nut, bolt, stud, or none of these? Okay. So, huh?
Nut.
Okay. So, Mr. Chandu and Mr. Pramod, you both are right. So, let's see. If I draw a nut, okay, this is nut, and if I draw a bolt, okay, so suppose this is our bolt, and if I draw a stud, this is stud, okay. So from this figure, you can see that the nut is having the internal threads, and our bolt and stud are having the external thread. Okay. So what is external thread? When the thread on when a thread are formed on the external surface of the workpiece is known as the external thread, and when the thread are formed on the internal surface of the workpiece is called as internal thread. So in the case of nut, only the internal thread is formed. So that's why the correct answer to this question will be nut. Okay. So moving to our next question. The axis of the thread is called as pitch line, pitch, depth of thread, angle of thread. Anyone? Any other option? Okay. Let's see. The axis of thread is the imaginary line running longitudinally through the center of the screw. And it is also known as the pitch line. Okay. So the correct answer is pitch line. Okay. So what do you mean by pitch? Can anyone answer? Okay. Okay, I will draw. Yeah, Chandu. Yeah, Mr. Chandu, tell me.
Sir, the distance between two successive threads.
The depth of the thread.
So I will draw different terminologies. Okay. So please tell me one. I will draw some terminology. Okay, so this distance is known as. Sorry. Okay, let me correct. Okay, this distance is known as. Anyone? So this is the distance between two corresponding points on the adjacent thread, and it is measured parallel to the axis of a thread. That distance is known as pitch. Okay. So then we talking about the angle of the thread. Okay. So this is the angle of thread. So what is angle of thread? Anyone? So angle of thread is the angle between the flanks of a thread measured in the axial plane, and it is also called as the included angle. Okay. Then we have this angle. Okay. This is alpha. Okay. What is alpha? It's angle of thread. This is flank angle. Okay. So what do you mean by flank angle? Anyone? So it is the angle formed between the flank of a thread and the axis perpendicular to that of the thread axis. Okay. So this is nothing but our flank angle. So these are some basic screw thread terminologies that you should remember. Okay. So moving to our next question. The thread gauges that are used to check the external thread form are called plug screw gauges, ring screw gauges, external screw gauges, both A and B. So this is A, this is B, this is C, and this is D. Okay. So anyone?
Sir, external screw gauge.
Any other option? Any other option, Mr. Pramod, Mr. Janardhan? So, Mr. Chandu, you are a bit wrong. The correct answer is ring screw gauges. Okay. So, in the very beginning, I have told you that the types of gauges based on their form. lug screw gauges and the ring screw gauges. So among these two, we use ring screw gauges to check external thread form. Okay. So any doubt in this one or any? So moving to our next question. Which of the following is not not a type of gears? Spur, worm, bevel, cycloidal. Anyone?
Cycloidal, sir.
Okay. Any other option? Yeah, Mr. Chandu, you're right. So these above all three are the types of gears. Okay, but this cycloidal is not a type of gear. It is the type of gear profiles. What are the different types of gear profiles? First one is cycloidal, and second one is anyone? Mr. Chandu, Mr. Janardhan, what is the second type of gear profile? Mr. Roderick, can anyone?
Sir, involute.
Yeah, involute. Yeah, you are right. So these are the profiles of gears. Okay. So this question was very simple. Okay, like if you know the types of gear and what are the profile, you can easily answer. Okay. So moving to our next question. So it's the gears are usually used to connect the shaft at desired angle to each other. Which of the following gear is used to connect the shafts at desired angle to each other? Herringbone gear, helical gear, worm gear, or bevel gear? Anyone? Okay, so Pramod is saying we can use bevel gear. Any other option? Mr. Roderick? Mr. Janardhan? Okay, let's see. So these are the three different types of gear. This one is herringbone. This one is worm and worm wheel. And this one is helical. Okay. So here in these gears you can see that the axis. Okay. Sorry. Okay. In this herringbone gear, you can see the gear profile like this. That it will have some double helix. Okay. And that we use to transfer the power. Okay, but the axis means we can't change the axis. Once the axis is fixed, it will remain fixed. Similarly, in case of helical gear, we can use to transfer it in the parallel shafts or if some misalignment will be there, we can use. Similarly, here we can use worm and worm wheel when the axes are perpendicular to each other. Okay, but when it comes to the bevel gear, you can see we can arrange bevel gear in different position. Okay, we can transfer power at an angle of 45, 80, 50 or 20 degrees respectively. So if we want to transfer power to the shaft at a desired angle, we generally go with the bevel gear. So the correct answer will be the bevel gear. Okay. So moving to our next question. It is the circle from which the involute form of the truth profile is generated. Base circle, outside circle, pitch circle, root circle. Anyone? Anyone? It is the circle from which the involute form of the tooth profile is generated. Base circle, outside circle, pitch circle or root circle. Anyone?
Sir, root circle.
Okay. Any other option? So let me draw the gear tooth profile first.
Base circle.
Okay. Any other option? This is our pitch circle. This is our base circle. This one is outside circle, or we also call it addendum circle. And we will have one more circle, that is the root circle. Okay. So the involute profile is generated from the base circle only, and it is the fixed and unalterable. Okay. So the involute profile, it will begin from this point, that is from base circle. Okay. And the root circle one is the circle corresponding to the minimum diameter of the gear profile. Okay. So it will give the minimum diameter of the gear profile. The involute profile is limited only up to the base circle. Okay, it doesn't start from the root circle. It always starts from the base circle. So the correct answer will be the base circle. So as we have drawn the sketch of this one, we will try to see some terminology. So I will draw first one. So what is this distance called? Anyone? The one in the orange here. Anyone? Anyone? Mr. Chandu, Mr. Janardhan? What is this distance called that I have drawn in the orange one? This one. Okay. So this distance is known as the tooth thickness. Similarly, if I measure distance between two consecutive points on adjacent teeth, so it's known as pitch. Okay. So the distance between the outside circle and pitch circle is known as anyone? This is the live interactive session, man. Please interact. The distance between outside circle and pitch circle is known as this distance is known as addendum. Okay. And the pitch circle and the distance between the pitch circle and root circle is known as
Dedendum, sir.
So if I convert this image in 3D, okay, like this one. So this the distance means the surface between the addendum circle and dedendum circle is known as face, and this one is flank. So these are some basic gear terminology that you should know. Okay, so you can receive the question in means sometimes in the interviews people can ask some basic question based on the gear terminology. Okay, so you should be aware of these things. Okay, so moving to our next question. In the gear tooth caliper method, for the measurement of the tooth thickness, blank space vernier scale are used. How many vernier scale are used in the gear tooth caliper method to measure the tooth thickness? 0, 1, 2 or 3? Anyone?
Two, sir.
Okay. And what are those? Okay. So, as you have seen in the lab demo, Okay, I am just drawing the rough sketch of the gear tooth caliper. So here you can see we have one vernier scale. Okay, and here we have second vernier scale. Okay. So what we do using this vertical one, we fix the height same as that of the addendum, and then using the second this second vernier scale, we measure the tooth thickness. Okay. So in the gear tooth caliper, we use two vernier scale. Okay. So any doubt in this one? Okay, like most people get confused how we are using two vernier scale. So this one is the whole assembly, but this one is the whole assembly. Okay, but in this one we are using two different scales. One is the horizontal one and one is the vertical one. So vertical one that we will use to with respect to this plate, we will fix the height as that of the addendum, and then we will keep our tooth here. Okay, this is the pitch line, and then we will measure the tooth thickness by moving this horizontal vernier scale. Okay, so moving to our next question. Which of the following is not a part of a Parkinson's gear tester? Scale, dial indicator, sliding carriage, rack and pinion. Anyone? Mr. Chandu, Mr. Janardhan, Mr. Pramod, Mr. Karupasamy. Anyone? Mr. Rodrigue, Mr. Sudarshan, Mr. Sekhar. Okay. Which of the following is not a part of a Parkinson gear tester? Anyone? So, anyone? Anyone? Okay, so Parkinson gear tester is a composite method of gear inspection. Okay, so what we do, we take a one master gear and we will fix it here on the base plate. Okay, and then we will take a gear which is to be inspected, and that we will mount on the sliding carriage or the floating carriage. Okay, when we rotate the master gear, the gear to be inspected will also rotate, and if there is a deviation or run out or any change in the tooth profile, so this sliding carriage will move here and there, and that deflection will be recorded by will be seen on the dial indicator. So for this Parkinson gear tester, we must need the dial indicator. Okay. Similarly, we also need the sliding carriage. Okay, and also we need a scale. Okay, how much to align the gear properly or to set the gear properly, we need the scale. Okay, so only the thing that is not needed in this Parkinson gear tester is the rack and pinion. So the correct answer will be the rack and pinion. Okay. So if you have any doubt in this one, you can ask. Okay. Okay. Moving to our next question. The imaginary line running longitudinally through the center of the screw is known as axis of thread, length, size line, none of these.
Sir, axis of thread.
And axis of thread is also known as Mr. Chandu, the axis of thread is also known as okay. So this is the definition of the axis of thread or the pitch line. That is, it is the imaginary line running longitudinally through the center of the screw. Okay. So as we have seen previously, that I have drawn some basic screw terminology, screw thread terminology. In that we have shown that pitch line is also known as the axis of thread, and it runs longitudinally through the center of the screw. Okay. So moving to our next question. The diameter of the cylinder that touches the root of the thread is called major diameter of external thread, major diameter of internal threads, minor diameter of internal threads, none of these. Okay. So for your simplification, I will draw the sketch first. Okay, let's see, this is the internal thread and this is our external thread. Now answer this question. The diameter of the cylinder that touches the root of the thread is so this is the root portion, okay? This is the root. Anyone? Now it's very easy to answer the question. Anyone? Mr. Chandu, Mr. Rodrigue, Mr. Sudarshan, Mr. Janardhan, Mr. Pramod. Can anyone? The diameter of the cylinder that touches the root of the thread is known as major diameter of external threads, major diameter of internal thread, minor diameter of internal threads.
It is the major diameter of the external thread.
Okay. Any other option? So this is our crest, okay? So in external thread, the distance between this crest, okay, is the major diameter, and the distance between root in case of external it's minor, okay. But in case of internal thread, the distance between two crest is the minor diameter and the distance between two roots is the major diameter. Okay. When I take a cylinder, okay, and that touches the root of the thread, okay. So okay. So only if I keep a cylinder and try to push it in the external thread, it will not be possible to touch its so it will not touch the root part. Okay. In case of the internal thread, if I take a cylinder and if I push it and the cylinder touches the root of the thread, then it will become the major diameter of the internal threads. Okay, so the correct answer will be the major diameter of internal threads. So moving to our next question. In general, each of the screw thread is specified by effective diameter as it decides the quality of fit between the screw and the nut. True or false? Anyone?
So true, sir.
Yes, the correct answer is true. Moving to next question. In case of single start thread, the lead is smaller than the pitch. True or false? So I will write the definition, then from that definition you can answer. So lead is nothing but it is the axial distance moved by the screw when the screw is given one complete rotation. Now about its axis, okay. Now answer this question. In case of single start thread, the lead is smaller than the pitch. Anyone? So, okay. So, if you take a single start thread, okay, and if I give a one complete rotation to the screw, okay, as you can see, I have a pencil in my hand, and so let's assume this is the screw, okay, and I am rotating it, and I am giving it a one complete rotation, okay. So, it will move by one pitch, okay. It will move a distance that is equivalent to that of the pitch. So in single start thread, the lead is equal to the pitch. So this statement is false. That is, the lead is smaller than the pitch. Okay. Moving to next question. Which of the following ways is the simplest to measure the minor diameter of the screw thread? By using floating carriage micrometer, by using screw thread micrometer, or by using a screw gauge, or none of these? Anyone? Anyone? Mr. Chandu, Mr. Pramod, Mr. Janardhan, Mr. Sudarshan, Mr. Sekhar?
Sir, by using a floating carriage micrometer.
Okay. Can we measure it using a screw gauge? Okay, the correct answer is by using a floating carriage micrometer. Okay, so if you use any other device than like a screw thread micrometer or screw gauge, we can measure the external diameter. Okay, and but in that also the problem is that the thread will be at some an angle. Okay, so it will not satisfy the Abbe's principle and uh, will not give the accurate measurement. So that's why people generally prefer the floating carriage micrometer. Okay, I will draw the sketch for that one. So okay, let's. So here I will have a micrometer. This is the floating carriage. This is the base, and these green colors are the guides. Okay. So what we will do, we'll keep our sample between these two anvils. Okay. And using a diameter of known cylinder, we will hold it in the place of this one, and then we will move our floating carriage, and we will measure the diameter of the known cylinder. Then we will untighten that one, and we will remove the diameter of unknown cylinder, in the cylinder of known diameter. Then we will keep a screw whose internal minor diameter need to be measured, and then we will tighten using this screw gauge, and using the anvil, this different shapes of and the anvil, we can measure the minor diameter of the screw thread. Okay. So moving to the next question, the error in pitch caused due to improper ratios of cutting tool velocity to rotating velocity of the workpiece is called as pitch error, lead error, major diameter error, or one of these. So the pitch error is the ratio of improper ratio of cutting tool velocity to rotating velocity of workpiece. So the correct answer will be the pitch error. So moving to next question. The not go gauge checks only one dimension at a time. Can anyone?
True, sir.
So this not go gauge. Okay. Can anyone answer the principle behind the go and no go gauge or not go gauge?
Sir, in go gauge, it checks all possible dimensions like location and thickness, and not go gauge only checks one dimension at a time.
Okay. And that principle is known as?
Taylor's principle.
So the correct answer is the true, and it's Taylor's principle. So moving to next question. Which of the following is are common teeth in gear? Involute, cycloidal, both involute and cycloidal, or none of these? Anyone?
So cycloidal.
So the options given are the types of the profile in the gear. So we can see the gears with the involute profile and cycloidal profile. So the correct answer will be the both involute and cycloidal. Okay. Moving to next question. So what causes the backlash or the excessive excessive blank space errors will result in either friction between the mating teeth or backlash. Blank runout, tooth profile, pitch, none of these. Anyone? Okay. So the tooth profile. Okay. So suppose if I draw but first gear, this is the second gear. Okay. If the tooth profile, if the error is there in the tooth profile, what will happen? It will cause the friction on the surface. Okay. And also it will result in the noise and other things, and which are the backlash. Okay. So the error in the tooth profile causes the friction between the mating teeth. Okay. If the tooth profile is not correct, okay, means some deviation from the standard or ideal tooth profile, or the standard, the desired tooth profile, or we can say like if the tooth profile is not a desired one and some error or deviation in the tooth profile, so this will result in the excessive friction or the excessive friction or wear and tear of the gear. So with this question, we will wind up our session here. So we will meet in the next session on next Tuesday at this time only. So if you have doubt in any previous question, you can ask, or simply we can wind up our session here. So no questions. So let's wind up your session here. Let's wind up our session here, and thanks for attending. So see you next Tuesday.